In today's lab video, we will learn how to find the tensile strength of steel. So first, to perform this test, we need a sample of length 2 feet. And after taking the sample of 2 feet length, we will first measure its weight. So now we can see that the weight of the sample is 0.947 kg. Now we will mark the center of this 2 feet sample with the help of marker, and from the center to our left and to our right we will mark 4-inch distance. So this total 8-inch distance is our gauge length on which we will perform the test in universal testing machine. So in universal testing machine we will put the data, that is the weight of this sample and the length. So the automatically that will calculate us the diameter of this sample and will give us the strength after applying the load. So this is the universal testing machine on which we will gonna perform the tensile strength test of the steel bar. So it consists of a two jaw sets. This jaw system, the jaw system at the bottom are the fixed, while the jaws at the top are movable. So this is the panel button system with the help of which we will operate the jaws. Now first we will start the universal testing machine. Now I will on the power unit of this universal testing machine, and here we came. This is the software module of universal testing machine in which we will feed the data of our specimen. So we will select the tensile option, the first one. Now here we will add the weight of the specimen. So here we will enter the weight of the specimen, that is 1 kg, and here we will turn on the pump of the hydraulic system and will zero this applied load. And here we can see there the 200 mm, which was 8-inch gauge length of the specimen, which we will set in this universal testing machine. So it will automatically calculate the diameter of the specimen. So now we will place the steel bar in the universal testing machine. So with the help of it, we will move the jaws. And we'll fix the sample in it. So with the help of that panel button, we are adjusting the gauge length of steel bar inside the jaws. Okay, so the specimen is placed between the jaws. Now we will start the test. So the loading rate we will set is 12 megapascal per second. and here the start we start the test. So we will get the stress strain curve of the steel bar. That the sample is failed. Now we will measure the increase in length, and these are the load. Here we can see that the failure load, yield point load. So this REL is the yield load at the yield point, and REH is the load at the ultimate point, stress. So we can see that the sample is broke. So now we will measure the increase in length. The gauge length was initially 8 inch and now it is 12 inch. So the increase in length is 4 inch. Okay, so there's a slight mistake. Initially the gauge length was 8 inch or 200 mm. So after the test the elongation is 20 mm. So the final reading, your final length is 220 mm. So 220 mm minus 200 mm is the elongation in length, and if we divide 20 mm by 200 mm, it will give us the strain at the fracture point. So that's all from my side. So I will share the graph stress strain curve with you guys, and then you can find out the different stress at different points. Thank you so much.